In this lesson, we are going over and starting the special right triangles, before we get into our trig ratios. So in this lesson, we're focusing on the 45, 45, 90 right triangle. And so before we do that, we'll do this review up here. So I would say go ahead and pause the video and answer this first part. If the given square here has a side length of 2, what is the length of the diagonal? So here, given the side length, you're looking for the length of the diagonal. So go ahead and pause the video and try the U-try here on your own. And here we go. So if you got a side length of 2 here, which means side length of 2 here, and this is technically a right triangle, notice how you're looking for the hypotenuse, right? So this is just good old Pythagorean theorem. So I've got 2 squared plus 2 squared is equal to c squared here, which is 4 plus 4, giving us 8. But then, of course, is 8 the diagonal? No, right? Because we need to take the square root. Now, here we also reviewed simplifying radicals because we're now not going to write this as a decimal, we're going to write this as a simplified radical. So like for example, I could break apart 8 into radical 4 and radical 2 because now what is the square root of 4? Because it's a perfect square. So it's like focusing on perfect square factors. So what is a square root of 4? Well, it's 2. So what is the length of the diagonal with a side length of 2? It is 2 radical 2. So then if we had a side length of 5, so let's see. So if this was now a side length of 5, so same thing, right? 5 squared plus 5 squared is equal to c squared. So this is 25 plus 25, which is 50, but then take the square root. Now again, what is the perfect square factor of 50? 25, right? 25 and 2. Then what is the square root of 25? 5. So 5 radical 2. So notice the pattern here, right? Without even having to calculate, if we had a side length of 8, then what is going to be the length of the diagonal? 8 radical 2. And that is the pattern here for our first type of right triangle. Because keep in mind that this diagonal in a square also serves as an angle bisector. So this 90 has now been bisected into a 45-degree angle. So what we just solved was the 45, 45, 90. If we had a side length that was x, like 2 or 5 or 8, then if you think about it, right, this is an isosceles triangle. So the two sides are both going to be the same, right, just like our square. Then the hypotenuse, opposite from the 90, was not just x, right, but x radical 2. So this is the setup of the 45. So like here, if I wanted to know what's the value of x and y. Now notice we have our 45, 45, 90. So if one side is 8, then that means y is also 8, meaning x is equal to 8 radical 2. Now here, notice we have a radical. So here, well, this is a 45, 45, right? So if this side is radical 10, then b is equal to radical 10. Then let's write it out. That means a is equal to radical 10 times radical 2, right? Because it's 8 times the side times radical 2. Now we need to continue simplifying because this is radical 20. Now let's continue simplifying because does radical 20 have a perfect square factor? Yes, 4 times 5. Because what is the square root of 4? 2. So here a is equal to 2 radical 5. So 2, bring down the radical 5, and that's how you get a. So a is 2 radical 5, and b is radical 10. So keep in mind now the simplifying of your radical. Go ahead and pause the video then and try the U-try on your own. And here we go. So here, you have a 45, 45, right? So if this side was radical 6, then y is equal to radical 6. That means your hypotenuse here, the longest side, is radical 6 times radical 2, which gives you radical 12. Then simplify, because the perfect square factor that you can use in this case is 4 and 3. Then radical 4 is 2. So 2 radical 3. So x is equal to 2 radical 3 and y is equal to radical 6. Now you could do prime factorization. So like let's just say, right? If you break this down, you could do 2 times 6, right? Then you're done with 2 because it's prime, but you can break down 2 and 3 because then now notice after here, now we've got all prime. Now we do have a pair of 2's. So you take the 2's out and you're still left with radical 3. So notice, even going the prime factorization route, you'll still get to that same radical here, the simplified radical. So now going on to example 2. Here again, this is now our 45, 45, because notice the angles are the same. So in this case, we have a 45, 45, 90. Now, so if this side is 10 radical 2, then the other side is also 10 radical 2 here, which means that x is 10 radical 2 times radical 2, which here only multiply radicals. So this is 10 radical 4. Well, what is the square root of 4? It's actually a perfect square. 2. So this is just 10 times 2, which is 20. So the hypotenuse ends up being 20. And the other side was the same because it's an isosceles. So same thing here. Let's do another. If this side is 3 radical 5, we have a 45-degree triangle. Then y is also 3 radical 5. Then here the hypotenuse is 3 radical 5 times radical 2, which, again, simplify, only radicals like terms. So this is 3 radical 10. Now, can we simplify radical 10? Is there a perfect square factor? Well, no. And if you think about it, right, it's just 5 and 2, which you can't break either down. So this is the simplified form. So go ahead and pause the video now and try the U-try on your own. And here we go. So here you have your 45, 45, 90. So here isosceles, right? If this is 2 radical 2, then A is also 2 radical 2. Then B, the hypotenuse, is 2 radical 2 times radical 2. Then again, simplifying, you should have noticed that this is 2 radical 4, which is actually 2. So 2 times 2 is 4. So B is equal to 4. So now our last example here with the triangles. Notice how we're given that the hypotenuse, and how do we know that this is a 45? Well, because the both sides given to us just say x, which means they're the same. So if we have an isosceles triangle, then the base angles are the same, which means we have a 45-degree angle here. So that's how we know we have the 45, 45, 90. Now, if this is 5, keep in mind, this is supposed to be in the form of x radical 2. So what we have to do is we have to actually figure out what is x. So we're going to actually solve this equation here. We're going to solve for x. Well, right now it's being multiplied by radical 2. So what do we now have to do? Divide by radical 2. So x is equal to 5 over radical 2. Now, we cannot have a radical in the denominator. So now what we're going to do is we're going to rationalize this fraction here, the denominator. And what we mean by that is we cannot have a radical here, so we've got to get rid of that radical. So what we do is we're going to kind of rationalize, we're going to multiply by 1, but we're going to multiply by 1 in the form of radical 2. So whatever we do to the denominator, we also do to the numerator, because here, if you think about it, this is 1. Now we multiply straight across, right? 5 times radical 2 is 5 radical 2. Then you should have noticed we've been doing this in the previous. What is radical 2 times radical 2? Radical 4. Well, what's radical 4? Just good old 2. So notice how those radicals now go away and you are just left with 2. Now, can we simplify? Can I divide 5 by 2 evenly into a whole number? No. So this is the value of x. So these two side lengths are 5 radical 2 over 2. That is the value of x. That is the two side lengths. So again, we cannot leave this fraction as is. We need to rationalize. Go ahead and pause the video now and try this try on your own. Now, before we continue though, how do we know that we are going to use the same pattern here? How do we know that this is a 45? Because again, right, we have an isosceles triangle, which means the base angles are the same. So now go ahead and pause the video and try the try on your own. And here we go. So again, this hypotenuse is just good old 16, right? Which means it needs to be in the form of radical 2 here. So we're going to set up and solve for x. You divide by radical 2. But can you leave this in that form? No. So rationalize. We multiply, right, by radical 2 here. So this is 16 radical 2 over radical 4, which is again just good old 2. Now, can we simplify? Yes. 16 divided by 2 is 8. So this is 8 radical 2. The two sides are 8 radical 2 with a hypotenuse of 16. So now these are the last two problems we're going to do together, these two applications. So Mina is picking oranges from a tree in her yard. So here's her tree here on the ground. So if you think about it too, right? Tree in the ground, creating a 90-degree angle. She rests a 12-foot ladder against the tree. So here's our ladder, right? Diagonal, and that is 12 feet against the tree at a 45-degree angle. So against the tree, so a 45-degree angle, which means if this angle is 45, and so is our base angle here at the ground. How far is the top of the ladder from the ground? So how far up is the ladder? So this is what we're looking for. But again, in the end, both sides are the same, right? Because this is a 45, 45, 90. But we are looking for this height here from the top of the ladder to the ground. So now we're going to go through and solve. Well, this is the hypotenuse. So that means 12 should be equal to x radical 2. So now we need to solve for x by dividing by radical 2. X is equal to, can we leave our fraction as is? No, right? We need to rationalize. So radical 2 here. So now multiplying, you get 12 radical 2 over, well, radical 2 times radical 2 again is radical 4, right? Which is just good old 2. Then can we simplify? Yes, because 12 divided by 2 is 6. So this height here is 6 radical 2 feet, which also technically we could also answer the question, right? What is the distance from the base of the ladder to the base of the tree? 6 radical 2. Now, if we wanted to figure out approximately how many feet this is, then you just type in your calculator 6 times, sorry about that, 6 times radical 2, which is approximately 8.5 feet. So go ahead and pause the video and try this second application problem on your own. And here we go. So we have an art project in the shape of a right triangle. You should have noticed, and it said that There is a 92 centimeter, which is used for the hypotenuse. So here's our hypotenuse at 92 centimeters. The two legs are of equal length, which means that's how we know that we have a 45, 45, 90 because they're equal length, so isosceles. But now, how many more centimeters of wood do we need? So we actually need both of the lengths added together because we need to know how much more wood is needed for not just one, right, but both legs. So here we go. Again, your hypotenuse was supposed to be in the form of x radical 2. So again, here, divide both sides by radical 2. Then again, you need to rationalize the denominator. And some of y'all, I'm sure, have started noticing a pattern, which is fine. So I'm going to keep going, writing it out. But now here you get 92 radical 2 over 2. You can simplify this to 92 divided by 2, which is 46 radical 2. So this side here is 46 radical 2. This side here is 46 radical 2 centimeters. Now, technically though, combine them together and we're back at a grand total, right? Because we need both legs of 92 radical 2. However, if you think about this like in a real world situation, we will need the approximate centimeters. So 92 times radical 2 is approximately 130.1 centimeters.